Hi everyone, this video is an exercise 11b question 3. So we want to integrate this fraction in part A and also the other fraction in part B. So first of all, in part A, we have 1 over 2x plus 1. Now this is one of the sort of a standard results that you need to know because whenever you see a fraction such that its numerator looks like the derivative of the denominator. It doesn't necessarily need to be exactly the derivative, but it sort of looks like the derivative. Then one of the first things that you can try is just the natural log, because if you remember, in terms of whenever a function is like this in the form integral of 1 over x, then this is the natural log of modulus x plus c. And so that's just because whenever you have the natural log of any function, so like this, then its derivative is basically equal to, if you differentiate this, you will get f dash x over f of x. So that's why we said that whenever you see a function that its numerator looks like a derivative of the denominator, then you can think of len. Now in this case, normally when the answer is len, then we need to adjust the function. So it's sort of like a guess that we start with, and then we adjust that. So in this case, let's say maybe the answer to this integral is the natural log of 2x plus 1. Okay, and then let's try that. So the way that we can try this is just let's differentiate this and see if we get exactly 1 over 2x plus 1. So if you differentiate, we will get 2. 2 is is on the numerator, and then because that's the derivative of inside, and then the denominator is just the entire function. So as you can see, this is almost similar to 1 over 2x plus 1 with the difference that we have 2. So now we can just think of how can we get rid of these 2. So we can simply get rid of these 2 if we have a half. So the way that we apply this half is simply that's here. So essentially this is the answer. So this is the integral. Again, where did this half come from? This is just an adjusting factor that we just realized that if we have a half, then the derivative is going to be exactly this function. Now we can try again. So we have this half, which is a coefficient, and then 2x plus 1. So the derivative of top is 2, and then denominator is just 2x plus 1. And this half will cancel out with this 2, and then we just get 1 over 2x plus 1, which is exactly the same as here. So it's more like first having a guess and then adjusting that. Sometimes the first guess can be the answer, but usually we need to make a few adjustments. Now part B is sort of similar, but it needs a different technique because it is no longer len. Let's just try and see what happens. So if we have len of, let's say, this is always positive, so we can just write len of 2x plus 1 squared, and we want to differentiate. So if we differentiate this, so this is our first guess. Now let's differentiate and see if we get the same fraction. So if we differentiate, first of all, the denominator is the same, so it's 2x plus 1 squared. Now the numerator is the power comes down, and then the derivative of inside is 2, and then we'll have 2x plus 1 squared. Now what happens, sorry, not the power is 1 now. Okay, so what happens here is that we'll have 4 over 2x plus 1 squared. Sorry, not a squared, it's just to the power of 1, because we have this bracket above 2x plus 1, so that cancels out with this power. And that's the problem. As you can see, in the denominator we have 2x plus 1 squared, but here we have 2x plus 1. So this tells us that the denominator isn't the same, and we can't use the same technique as above, because in above the problem was just with the coefficient, and that can be solved easily. But if the problem is about it's directly related to the independent variable, then we cannot adjust in the same way that we just added the constant, because the constant is not going to solve this power problem, because here the power is not the same as here. So we use a different technique. Always, again, the first guess could be using len when you see fractions in this form. Now the second guess is that so first we write this in the form x to the power of n. So we just we have 2x plus 1 to the power of minus 2. Then add the 1 to the power, and this is our guess. So the guess is that this is the main function. When you integrate, this is the answer. Now again, in order to check our guess, let's just differentiate and see if we get this, and then based on that we can adjust this. So we always adjust the guess, so this is the guess. Now if you differentiate the guess, again the power is -1, then from inside we have 2, then we have 2x plus 1 to the power of -2, because power is reduced by 1. Now here we have -2, then 2x plus 1 squared. So just look at that. Now the denominator is exactly the same. We just have this -2 above. So this is similar to problem 1. Now in order to get rid of this -2, we need to have -1/2 here so that it can be cancelled. And yeah, so the guess that was here is just missing this term, -1/2. And that's basically the answer to this integration. So the answer is simply -1/2 times 2x plus 1 to the power of -1 plus c. This is a method that at first can be very confusing and it needs a lot of practice. But once you practice a decent number of these questions, then you'll see that this method is actually one of the simplest and quickest methods in integration.